Hi everyone, today we're coming back to the HSC 4-unit exam for the year 2000. So I recently worked through question 8 of that exam, the final question. Now we're taking a look at question 7, part A, and this part A has 4 subparts. So as usual, I'll look at each subpart in a separate video. So here we'll focus on part 1, and it says, show that for x greater than 0, the natural log of x will be less than or equal to x minus 1 with equality only at x equals 1. So I've just written out what we need to show, but I think before we get into the algebra and the calculus, I think it might be helpful to take a look at the chart of each of these elements of the inequalities. So the chart of log of x and the chart of x minus 1, because I think that'll give us a feel for what we're really dealing with this inequality. So I'll just draw up a little axis here. Maybe we'll just go nothing too drastic. It doesn't need to be particularly large. 1, 2, 3, 4, that's probably enough. So we'll just have our x, y, 0, 1, 2, 3, 4, 1, 2, 3, minus 1, minus 2, minus 3. So let's just label all this. Now hopefully most 4-unit students would be very familiar with the chart of log of x. It'll intercept the x-axis at 1, the log of 1 is 0. We know it doesn't hit the y-axis, we know the log of 0 is undefined, and it basically has this shape here, something along these lines. We don't have to draw it perfectly, but the key is that the intercept is here. Now again, the curve of x minus 1 should hopefully be very simple for any 4-unit student to chart. It's basically the x and y values are the same. When x minus 1, it's a straight line, x and y value isn't the same. Obviously that would be y is equal to x. But you can just pick values of x and you get the values of y. So when x is 0, we get y is equal to negative 1. When x is 1, we get, when x is 1, we get y is equal to 0. When x is 2, we get y is equal to 1. When x is 3, we get y is equal to 2. When x is 4, we get y is equal to 3. And that should be more than enough to then plot up our straight line. So that's kind of what we're dealing with. We're only really concerned with x greater than 0. Obviously we'll keep going, but that's the domain the question wants us to think about. So we've got y is equal to x minus 1, y is equal to the natural log of x. And you can kind of see visually that the natural log of x is always less than or equal to x minus 1 for this positive domain. And we get equality at x is equal to 1. So you can kind of see that this inequality is going to hold true. Now, I don't think you could stop there. If you did this and this is all you did in the exam, maybe you'd get a mark. But I'm pretty sure the question writer wants us to work through the algebra and use calculus to kind of demonstrate this outcome. I think the chart just helps you get your head around what you're dealing with. So now we're going to the calculus. So I think to start we can let y equal this natural log of x. And so naturally what we want to do is we want to differentiate it and then get the, I guess the equation of the tangent in particular at x is equal to 1. And I think we'll see, you can probably guess that we're going to get this curve here. And then if you can show that the curve is concave down, you basically have then shown that the curve will always be less than the tangent. Because if it's concave up, then sure, maybe it intercepts with the tangent. But if it's concave down, then it's never going to have an opportunity to get above this straight line. So let's find the first derivative. So the first derivative of log of x is 1 on x, or maybe it's helpful to just write that as x to the negative 1, because that helps us get the second derivative, which would be negative x to the negative 2, or in other words, negative 1 on x squared. So that's what we're dealing with. At x is equal to 1, what we get is that our first derivative would be 1 on 1, which is just 1. So we know that the gradient of our tangent at the point x is equal to 1, this point that we care about, is just going to be 1. And that's good news because that's consistent with the curve x minus 1, which also has a gradient of 1. Now we just need to get this curve, and essentially it'll be no surprise that we'll get to this, but we need to show it. So we know that the tangent will be a straight line. The tangent will follow the format y is equal to mx plus b. That's the general form of straight lines, but in our case, because we know the tangent's 1, the tangent at x is equal to 1 will be x plus b, simply. Y is equal to x plus b. So really we just need to find this b. We know that at x is equal to 1, y is equal to the log of 1, or 0. And so therefore we can say that 0 would equal 1 plus b. So that means our b will be -1. And so therefore our tangent line has the form y is equal to x minus 1, exactly what we're anticipating. So basically from there we can, as I mentioned, if we can show that the curve is concave down, then basically concave down for all x greater than 0, then basically we've essentially shown what we need to show, because as I mentioned, there's no opportunity for the curve to turn back around and kind of get above this straight line. So I think maybe what we could say is maybe we'd have to write that. I think in the context of an exam you'd probably need to make it clear that you understand that. So we might say if y is equal to log x is concave down, then it must always be below the tangent at x is equal to 1. And then from there you could probably say, given our y double dash, which we worked out is equal to -1 on x squared, well, that's always going to be less than 0, because you've got -1 up here in the numerator, and no matter what x you pick, x squared is going to be positive, and so -1 on a positive number will stay negative, and that's going to be for all x greater than 0, the domain that we care about. So therefore you can say y equals log x is concave down, and therefore we can do our final conclusion. Therefore this log of x will be less than or equal to our tangent x minus 1 for x greater than 0, and we already saw that we've got this equality at x equals 1. So with equality at x is equal to 1. Boom! And that's pretty much that question. I think showing the graph is probably helpful. Maybe not necessary. You could probably do this question without it, but I think it's helpful. I don't think the graph is sufficient if that's all you did. A generous marker might feel inclined to give you a mark, but I think to get all the marks up for grabs here, you'd need to work through this calculus and really make clear that you understand that if you've got this tangent line and a concave down curve, then the curve never gets above the line. So hopefully that all makes sense, and that's something you could do now independently if you had to. And in the next video, I'll work through part 2 of this question. Tick boom!